This week's topic is density, and this is the most important topic we'll have this year because density is the basis for everything we will study in earth science this year. The basic idea is that less dense substances float above more dense substances, and we can see in this diagram that the heaviest substances are on the bottom and the lighter substances go up, and density explains how substances interact with their environment. The formula for density is on the first page of your reference table, and it's equal to mass divided by volume. Mass, as we've already said, is the amount of matter that an object has. Volume is the amount of space that an object takes up, and density is the amount of matter in a given space. This is an example of a density problem. Here's the formula for density. Density equals mass divided by volume. And a little trick here is you could take the numerator of a formula like this and put it into the top of a triangle. So we have mass on the top and density and volume on the bottom of this triangle. And here's an example. We have mass equals 8.0 grams, the volume equals 2.0 milliliters, and we don't know the density. So since we're looking for density, we're going to come back over to this triangle and we're going to cover up the thing we're looking for. So now we have mass over volume, and that's the formula we're going to use. So we're going to say that density equals mass over volume, and then we're going to say that we're going to plug in the values. 8.0 grams is the mass, and the volume is 2.0 milliliters. When we divide 8 divided by 2, the density equals 4.0, and nothing cancels. We have grams over milliliters, so we're going to have grams divided by milliliters. Here's another example of a density problem. In this example, we have the volume is 2.0 milliliters and the density is 7.0 grams per milliliter, and we don't know the mass. So since we don't know the mass, we're going to come up to this triangle. We're going to cover up the thing we're looking for, and now we have density next to volume, which means density times volume. So we're going to set that up, that mass equals density times volume. So the mass equals, the density is 7.0 grams over milliliters, and that's all in the given information there. And then we're going to have this times 2.0 milliliters, the volume. When we multiply this out, we have 7 times 2 is 14. So the mass equals 14. And we have grams over milliliters over here, and we have milliliters on top here. So these milliliters actually cancel, and we're just left with grams. There are two ways to change a substance's density. The first is you can change its mass, and the second is you can change its volume. To understand how we can change its mass, we need to know a little bit about the periodic table of elements. This is a list of all of the known types of atoms that there are in the universe. And the basic idea here is as you go from left to right and from top to bottom, you generally increase in mass. So, for example, hydrogen is the first element, and its atomic mass is about 1 atomic mass unit, and helium's atomic mass is about 4 atomic mass units. So helium is about 4 times more massive than hydrogen. You can also change a substance's density by changing its volume. The volume of a substance is closely related to temperature. Let me explain. Imagine a closed tube with 5 atoms inside. If we add heat energy, the atoms begin to move. Temperature is a measurement of the average motion of these atoms. The more atoms bump into the thermometer, the higher the temperature. In this scale here, we can see that there are 3, this is on page 13 of your reference table, and you can see that there are 3 scales for reading temperature: Fahrenheit, Celsius, and Kelvin. On this green line right here, you can see that 100 degrees Fahrenheit is equal to about 37 degrees Celsius and equal to about 312 degree or 12 Kelvin. There's no degree when you say Kelvin. So to increase the temperature, there's 3 basic things you could do to those 5 atoms in the tube. The first thing is you could add more heat to speed up the atoms. The second thing is you could add more atoms. That would also increase the collisions with the thermometer. Or you could shrink the container. And now that we know how to change the temperature, now let's find out what happens to the matter when we change the temperature. First, let's decrease the temperature. To do this, we would do the opposite of the three things we did before. So we would decrease the heat, we would take away atoms, or we could increase the size of the container. And if you do that, then we would have liquid turning into a solid. And notice how many more atoms are packed into that same space in a solid. To increase the temperature, we would do the same things that we mentioned before. And when this happens, we would have a liquid turning into a gas. And in a gas, the molecules or atoms are moving a lot faster and they're more spread out. This table is very important. Then it shows the temperature, the relative temperature of each. So a solid has a low relative temperature and a gas has a high relative temperature. And then lastly, it shows the density, which is how closely packed those molecules are into a given space. And in a solid, it has a high relative density, and a gas has a very low relative density. On page 1 of your reference table, we have the properties of water. And this tells us exactly how much energy it takes to have water change its phase. In this diagram, we can see that same concept from the previous slide, just with arrows. And you'll notice that, for example, a solid ice, when it melts, it gains 334 joules per gram of stored heat and becomes a liquid. And that liquid evaporates, and it takes 2,260 joules per gram to become a gas. And then going back the other way, when that gas condenses and turns back into a liquid, loses 2,260 joules per gram. And when it goes from a liquid to a solid to ice, as it freezes, it is going to lose 344 joules per gram of stored heat. The last piece of this is that water can actually skip the liquid phase. It can go straight from a gas to a solid, and we call that frost. And it can go from a solid straight to a gas, and that's called sublimation.